Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about the application insertion sort belongs to decrease and conquer algorithm design strategy. Insertion sort is a simple sorting algorithm that works in a similar way how we sort playing cards in our hands. So here it is assumed that the first card is already sorted in the card game. So suppose if you are playing a card game, the first card is already sorted. We select the unsorted card. If the selected unsorted card is greater than the first card, it will be placed at the right side. Otherwise, it will be placed at the left side. So suppose, for example, here you have a card and here you have a card. The card value is 3. Here the card value is, let us say, 2. We assume that this first card is already sorted. Now we will select the next card. Now we will take the value which is present in the next card. We compare the value of this card with this card. If it is greater, we will put it in the right side only. If it is not greater, then we sort them as like this. Here the card comes to left side, the card which contains a value 2 comes to left side, and the card which contains a value 3 comes to right side. The same way, there may be another card, right? So its value may be, let us say, 6, right? Now here we take the next unsorted card. We compare this unsorted card with the previous sorted cards. If it is greater, then it will be kept in right side. Otherwise, it will move to the left side. This procedure is to be continued till all cards are sorted. Right. So in this case, the array is virtually split into a sorted and an unsorted part. The values from the unsorted part are picked and placed at the correct position in the sorted part. Right. Now, this is an in-place comparison-based sorting algorithm. This is to be called as in-place comparison-based sorting algorithm. Right. So how we can write the algorithm? So here you can see the steps which are present in the algorithm of insertion sort. Start with the second element and consider it as the current element. Generally, suppose let us take this is my array. First element is present at the index 0, second element is present at the index 1, and so on. If my array contains n elements, the n minus element is present at the index, the nth element is present at the index n minus 1 position, right? So we start the procedure with the second element. That is, with this element we start the procedure and we consider this as the current element, right? Compare the current element with the one before it. So here we are going to compare these two elements, the element which are present at this index and at this index. So whether these two elements are equal or greater or less, that we are going to compare, right? So if the current element is smaller or equal than the previous element, then move the previous element 1 to the right position. Okay, so that is, if this is smaller or equal, then we need to move the element which is present here to here and the element which is present here to here. So this step is to be repeated until you find an element that is smaller than the current element or until you reach the beginning of the array. That is, so suppose for example, if you find any element, smaller element here, so first you need to compare with this. So if it is smaller than this one, then you need to move it here. Again, this is to be compared with this. You need again move it to here. So like that, this process is to be continued till you get a smaller element, till you find a smaller element before that, or otherwise till it reaches this end of the array. So insert its current element into the correct position and move the next unsorted element. Here the procedure moves to the, after inserting this element, the procedure moves to the next unsorted element, right? So this is the process of insertion sort. So here I'm going to play a small video which shows the procedure of insertion chart. Try to understand that. Right. I hope that you all understood the procedure. Again, once again, we are going to see how this works by taking one small example. Let us see this example. So here you are given a list of elements. So first, in case of insertion sort, first we need to take the second element, the element which is present at the position 1. That is, we are considering 33. So here now 33 is compared with 14. Now, when I am comparing 33 with 14, 14 is the less element, so we cannot swap them. So the 14 is present in its correct position. So after that, we are going to take the next unsorted element, which is nothing but 27. This 27 is compared with 33 first. Since 27 is less than 33, now we need to interchange these two. These two are to be interchanged. 27 comes here and 33 comes here. Now again, we are going to compare that 27 with 14 as well. Now, when I am comparing that 27 with 14, since 14 is less, these two are not to be swapped. Next, our procedure moves to the next unsorted element, which is nothing but 10. Now, 10 is compared with 33. Since 33 is greater, first 10 moves here. Now, it is compared with again 27. Since it is greater, 10 again moves to 27 place. And again 10 is compared with 14. Now 10 move to here in this place, right? Now 10 is in the correct position. After that, we need to take the next unsorted element, which is nothing but 35. So since it is greater than all of these elements, this position cannot be changed. Next, we will take the next unsorted element, 19. So we'll compare it. Next, we interchange the positions. Here 19 comes and here 35 comes. Next, 19 is compared with 33. Now here 19 comes. Here I will get 33. Now here these two are compared. Now here 19 comes. Here 27 comes. Now if I am comparing these two, the 19 is in its correct position. After that, we go for moving next unsorted element. So if you observe 35, 42 and 45, all are sorted. Right. This procedure is to be called as insertion sort. So you can see one more example for insertion sort. So here you can see this is the given list of elements. First 3 is compared with 4. These two are swapped. Next 2. 2 is compared with 4. First these two are swapped. 4 comes here. Next 2 comes here. 2 is compared with 3. Then 2 comes here. 3 and 4. Next 10. So since 10 is greater than all these, its position cannot be changed. Next 12. 12 also greater than all of these, then its position cannot be changed. Next, if we see, next element is 1. Now, here it is going to be compared with the consecutive elements all. So it comes, since it is less than all these elements, it comes here. So 1 is positioned here, remaining all are positioned like this. Right. Again, we go for 5. Next, we go for 6. The same way, we get the sorted list finally. This procedure is to be called as insertion sort. Right. The time complexity for insertion sort is big O of n. If n is the number of elements or number of items that are given, big O of n is the best case time complexity. But if you take the average case or worst case, the time complexity becomes big O of n square. So I hope that you all understood this insertion sort example and algorithm. So we'll see the next applications in the next session. Thank you for listening.